Thank you everyone for jumping on. We're going to get started in just about a minute. And anyone that joins after that can catch up as we go. All right, awesome. We are right on time. We're going to get started. It's great to see everyone who's on the webinar jumping on. So today we're going to be covering an analytics series, the first of 3 webinars that I'll be delivering over the course of this month. So a quick introduction on myself. My name is Eric Lind. I am a solutions architect at Databricks, and I currently support accounts within our manufacturing industry. But I've been using Databricks for quite a while, and I think even if you don't work for a manufacturing company, a lot of what you see today is going to be applicable to the work that you do. But the use case that we're going to walk through kind of in a simple fashion today is kind of guided around that sense. So the agenda for what we're going to be covering today is, again, the first part, we're covering Databricks SQL today as the first part of this 3-part webinar. And then over the course of the next 2 weeks, I'm going to be covering AI/BI dashboards and AI/BI Genie. So for today, the focus is on Databricks SQL. So a lot of you that joined, I imagine, fall into the persona of a data analyst, a business user. Your title may have analyst of some sort, operations analyst, business analyst, whatever that might be. The goal of today is to help you better understand how to leverage Databricks SQL capabilities. Mostly the ones that are native to the platform, but I will highlight a few things about how, for example, you can leverage Databricks SQL warehouses to connect to your BI applications. But really the goal of today is to help you understand how to better navigate and utilize the Databricks platform for your SQL-based analytics. In the next 2 webinar sessions, we're going to be covering dashboards and Genie, each in their own separate session. So hopefully that will allow you all to get a really good sense of the full suite of capabilities available to you in the platform in a very real sense and use case. If you have questions throughout the webinar, please make sure to use the chat feature. We are going to do our best job to monitor those as we go. I have the chat up, so if I get a question asked about a topic that I'm covering at the moment, I'll do my best to follow up on that live. But we also have someone else here, Grace, who's going to help out with some of the Q&A on our side. So Grace is another SA from Databricks joining us. So we're going to do a quick introduction, just giving you a background on Databricks, some of the terminology that you're going to hear, things like Unity Catalog, warehouses, et cetera. And then we'll dive into the demo. So a majority of the time spent today will be live in the platform. It won't be all slide-based, but do want to give everybody kind of a level setting in case you're not already familiar with the platform to its fullest extent. So let's dive in. So Databricks SQL. If you know a lot about Databricks, you know that Databricks was founded back in 2013. It really began as a data science or a data engineering application that expanded the capabilities of Spark into a managed platform. But over time, we realized that a lot of our customers were asking us not about their data engineering or data science-based workloads. They were asking about data warehousing workloads. And so some of what we gathered from feedback from those customers is that their existing solutions at the time had lots of challenges. They were often closed off or standalone from the rest of their data and AI ecosystem, meaning they had either a data warehousing solution or a database solution that was very purpose-driven for maybe an application or a reporting suite. But what that led to is kind of a discombobulation between where their data lived, how they apply governance on all of that data, how they use that data for various different use cases, having to copy it between different systems, and then having to manage all those applications effectively to run their business at cost became a real challenge. So Databricks evolved and built these capabilities several years ago now, back in 2021, and has evolved into an industry leader for all of the reasons that you see here today. Databricks SQL warehousing is an open, unified, and very cost-effective solution for running analytics workloads. We use the phrase open to talk about our open support for open data formats, Delta, Iceberg, CSV, JSONs, any of those formats that you store your data in, Databricks can leverage those. Doesn't lock you into any proprietary formats or components that are needed to run your analytics operations. It's a unified component of the Databricks platform. So when you use Databricks SQL, you're using it in conjunction with Unity Catalog in Databricks, which provides governance over all of your assets. It provides cataloging and metadata capture for all of your data. And then on top of that, in Databricks, you of course have other capabilities like running notebooks, ETL, building your AI solutions, things like forecasting, ML models, large language models, all those things are built in. So we can unify your analytics and data warehousing workloads with other workloads with the same types of data without having to replicate it for various different purposes. And then on top of that, we offer the best price for performance in the market, demonstrated publicly in lots of our other benchmarks and blog posts you'll see in a few minutes as well. So this is what we're covering today, is the data warehousing solution on Databricks. This is one product in a vast ecosystem of products that our platform supports. And you see that there's a lot of bubbles on this page. Some of these are very new, but it just kind of shows you how fast the platform is innovating. So on this page, we're going to be talking about Databricks SQL today. But the really nice thing is that the SQL product in Databricks integrates with any and all the things that you see here on the page. So if you want to use Databricks apps to pull data out of your data warehouse to surface reports in an application to end users, you can very easily tap into that and integrate that with your applications. You can run your AI BI workloads using Databricks SQL. You're going to see in a few minutes how you can leverage AI query or AI functions from Mosaic AI in Databricks SQL as well. So all these different components are really integrated, and that's kind of what differentiates the Databricks platform from other solutions on the market today, is that it's not a point solution designed for one purpose, right? We have a lot of these purposes built into a solution that's integrated natively with lots of other features, right? So much so that we've had a lot of success across all industries. You see a few examples of other manufacturing customers using Databricks today, and we've got a lot of adoption across all Fortune 500 companies and companies of various sizes, right? So the platform has gotten to a point where it's extremely well proven out that it is the best price performance in the market, really feature rich and supportive of lots of different types of workloads and things that your teams likely do today for analytics. Some recent other benchmarks that were published around Gartner and Forrester demonstrate that Databricks is, again, a leader in these categories. If you look up or Google these links, you can probably find a lot more reading material than we'll have time to cover today. But just again, demonstrating that Databricks is a leader in this category, and we have lots of features that should be able to help you out. So before we go back into the demo, I want to just talk a little bit more about some of those things that we talked about before about what differentiates Databricks, right? I mentioned open, unified, and lower TCO. So let's talk about those things a little bit more in depth before we dive into kind of the walkthrough of the platform. So open formats, right? So when we talk about open by design, we're talking about open formats, open catalog, and open ecosystem. So Databricks is capable and natively supportive of any one of the file formats that you're most commonly choosing today for a data lakehouse solution like Delta or Iceberg. A few years ago, there was a big discussion and debate around, do I need to pick one of these formats based on the actual results that I want to accomplish on my data? Is Delta or Iceberg more performant for ETL versus analytics? What support do those solutions have across different other applications or systems that we want to integrate our data with? Databricks really kind of removes away that need to decide, or the headache around which one you should be choosing, because we support both completely. So if your data is in Delta, Iceberg, CSV, JSON, whatever that might look like, you can use that data within Databricks, right? It's fully open. You can take that data from your cloud storage layer, use it in any other application, but it's made most effectively used inside of a lakehouse in Databricks. On top of that, we have an open catalog that we call Unity Catalog. It's also open source, where we allow you to read and write your data from any engine. So again, it's eliminating that need of vendor lock-in or proprietary data format lock-in. You can use Databricks to read and write from any external engine, as well as, of course, from the Databricks engines that we offer, to read and write your data sets that you want to leverage for analytics and other solutions. On top of that, we have a vast open ecosystem of integrations with other partners in this space, everything from BI solutions to AI tooling, ETL tooling, lots of other different components. So if you have other applications that you leverage in conjunction with your lakehouse, you can very easily look at how Databricks integrates with them to get the best bang for your buck and not require you to have to re-architect the entire solutions. We integrate very well with lots of other providers out there in the space. So I know today we're going to be focusing on Databricks SQL, but I do want to highlight that a big component about what makes Databricks SQL a leader in this category is that it does come with Unity Catalog, which is both a catalog and metastore layer, as well as a governance model for any and all of your data. So it really is kind of two different applications or sets of features combined into one system that really help to make it easy to manage and work with your data. So whether you're trying to use data that is natively stored in Databricks, whether you're trying to read data that's from another database or another application that you want to federate queries from through Databricks, you can do that through Unity Catalog, use Databricks as kind of the central hub for analytics to write queries from your data. So if you have data in another database, like a Postgres database or Snowflake or SQL Server, you can still use Unity Catalog to federate queries from our platform and application into those databases. So it helps out with that kind of unification of data all in one platform that you want to use for analytics. On top of that, Databricks SQL is just one product that's integrated with everything that you see in Databricks for ETL. So with Databricks, you can certainly build data pipelines through notebooks, through our workflows features. You can also use SQL queries in workflows so that you can run your queries that will generate or update or create tables on a regular basis and use SQL transformations to run your data pipelines. Very easily done through Databricks today. I'll highlight this very briefly today, but the goal of today is not data pipelining, it's mostly analytics, right? So if you're interested on that, certainly would encourage you to read more about through our documentation or our existing public demos. And then on the last component of what we mean by unified is the ability to tap into AI. So with Databricks SQL, you're not just given standard query support for your data. You can also leverage lots of our support with models that you want to build and develop on the Databricks platform. You can use open foundational models on Databricks, and you can use a lot of our built-in native support called AI functions to run queries on top of your data. So if you have a custom model that does forecasting or a custom model that does sentiment analysis on reviews or product part descriptions, you can use those functions natively through SQL, so it makes it really easy for your end users to leverage and tap into the power of what those models offer in a single interface in a single application, right? So if you want to build a model that does something like filter out images for a particular type of category using a custom function, or use a function that parses text from a document into a Delta table or a Databricks table, you can use some of these functions natively in a SQL function or a SQL query to support some of those more advanced use cases, right? So helps out with that native support and integration with other AI solutions. Again, helping out with both TCO, time to value, to accelerate the development of your data products and analytics. And on top of that, these are kind of some of the things that maybe are not visible to you as you're using the platform natively, but we offer the best price per performance and the lowest TCO of providers out there in the data warehousing space. The ways by which we're able to do that are some of what you see here on the page. So when you leverage some of the more kind of advanced supported features in Databricks, like predictive optimization, what that allows Databricks to do is effectively manage your Delta tables, your kind of raw files in Delta storage in a more efficient fashion, rather than you having to be responsible for managing and tuning things like file sizes, running vacuum and optimize commands on your Delta tables. Databricks can learn from the behavior of how your analysts and other end users are leveraging this data and run those types of commands in an automated fashion that makes your tables as efficient as possible in an ongoing basis, right? So typically analysts are not going to be responsible for all different types of queries or of management on your tables, but you may be required to understand how to optimize performance, right? So these are things that are important for you to understand as an analyst. as well. Couple more slides, then we'll dive into the demo here. So we talked a little bit about three things: open, unified, lower TCO. All those things are great, but of course they don't mean anything unless you have performance built in, right? We talk about TCO as price per performance, but with Databricks, we also talk about performance being a key crux of the end user experience. So here's the kind of a chart that shows our relative performance increases of standard Databricks SQL queries. This is kind of out of the box queries without having to run all types of commands to optimize a table. So you can see that over time, the performance increases have been pretty significant on Databricks. So if you were to run the same query that you did 4 or 5 years ago on Databricks SQL, you're going to see likely 5 times faster performance, right? So our teams are constantly innovating on features, but also innovating on performance to make sure that you have the best experience, the best data warehouse that you can possibly leverage on the market today. So definitely encourage you to test these things out with your data to see it in action. We have some benchmarks and comparisons to other cloud warehouses in this space that demonstrate that no matter what size and scale of data you're working with, Databricks can handle and work with that data effectively. So there should be no limitation in terms of what you actually want to accomplish and use on Databricks. So again, encourage you to go and try things out with your data to test this out at scale. So I've already covered these things quite a bit. Just wanted to flash one more quick slide as a reminder, and then jump into a quick walkthrough of just kind of the example use case for today, right? So I mentioned we're going to be walking through a simple simulation for a manufacturing company that wants to manage their supply chain effectively. They may want to understand, can we handle things like an increase and spike in sales? Are we capable of handling that through our supply chain? Are there particular bottlenecks or suppliers that we need to be worried about? Can we identify the specific part numbers that we should be worried about as well, right? All those things are going to be very relevant for somebody in this space. And so I wanted to give a quick background into what we're going to be covering with the actual data. But again, even if you don't work for a manufacturing company, this is just something that you can hopefully make some similarities to the work that you do, right? So in the lens of somebody who's focused on supply chain, the things that you care about and need to worry about are delivering or ensuring exceptional and high on-time delivery, on-time and full delivery, making sure those metrics are always as high as they can be, making sure you have the parts where they need to be at the right times. You need to make sure that you can accelerate the planning cycles, making sure that when you want to release a new product, a new SKU, you have the parts and demand to support that, accelerate time to market for new products. Eliminate manual processes. So we talked about a little bit on the technology side, where oftentimes people will choose a database or have a database or a warehouse today that may have been designed or purpose-built for one line of business or one application. That often leads to a lot of manual work that's done to consolidate data systems. You might have your parts and inventory data stored in a separate location, then you have your sales data, which might require you to either copy or manually extract and combine that sort of thing. But the goal would be for any supply chain analyst to not have to do that, have all their data in one ecosystem available at one time to do all the analytics that you want to run, right? The challenge that a lot of companies face is that those things are a lot easier said than done. There's always different types of events, like complexities with your business, complexities with politics, things like tariffs have thrown companies for a loop since the beginning of this year. So it's a constantly evolving environment where analysts don't always have the same conditions today as they did yesterday. So it requires them to have easy access to their data to make things easy. Instead of having too many tools for each purpose-built application, instead of taking hours or days or weeks to consolidate some types of analytics, companies need to be able to do that type of analysis when they want to reallocate parts or do some sort of inventory management analytics. They want to be able to do that in real time with their data connected all in one system, right? So you can see here a couple of quotes that we've heard from other customers that with their existing products prior to using Databricks, it's a challenge to do all of this, right? There's a number of different components in this. I'm probably going to skip over this slide just for the sake of time, but the goal is that with Databricks, you can kind of eliminate a lot of these challenges and silos on our platform. You have a unified system for handling data ingestion, transformation, analytics, building AI models, integrating them all in one solution. So no longer do you have to worry about your supplier, inventory, sales, production data all coming from different systems. You have it all under one roof when you use Databricks to its fullest extent, right? So let's dive in here and kind of give a quick walkthrough of how you can best tap into Databricks platform and leverage Databricks SQL. So quick reminder, I don't think we're blocking anything, but I haven't seen any questions come through the chat, but hopefully you have access to the webinar chat. Please do leverage that in case you have any questions. We'll do our best to answer these in real time. So to start with, I mentioned earlier that I know we're going to be focusing on Databricks SQL. However, when you talk about the Databricks platform today, it really is important to understand how to explore data that already exists, right? Of course, you can't do any analytics unless you have data to access, right? You need to have data access, you need to have compute to actually run the workloads and queries that you want to run. So before we dive into the editor, we're going to talk about Unity Catalog and our compute options for SQL warehouses. So inside Databricks, here on the left-hand side, on the nav page, we have Unity Catalog. Unity Catalog is the central framework by which you can explore all of the data sets that you have available to you in your Databricks workspace, right? So Unity Catalog stores different objects like tables or different files in what we call a three-level namespace. So you have different catalogs here. That's the top level, the first level namespace. So I have a catalog here called Demos Genie. I have a schema here called Manufacturing Operations Planning. And I have tables here that you can see that we're going to be using for the demo today. Things like auto bill of materials, auto part forecast. So just like any other database or data warehouse solution, you have a way of referencing your tables and objects in a very native fashion and format. But Unity Catalog offers a lot more than that. So within each of these tables and objects, you can see that you have the ability to look at the metadata, the permissions, the governance policies built in on top of your data. So as an analyst, unless you're actually creating data assets, maybe you're not going to be responsible for applying permissions, but it's important, I think, for you to understand how these things work and what the benefit of using them is in the platform. Today, we're not going to focus on Genie or dashboards as well, but imagine that you wanted to take some of this data. You'll see this again in the next couple of weeks if you join the other webinars. Imagine you wanted to build a dashboard or enable natural language querying on top of your data sets. The way by which you can make that experience better and get more accurate responses is to add things like comments and metadata, table descriptions to your tables so that our natural language engine can better understand the context of what these tables mean, what your columns mean, what they're used for, how they're created, how do these tables relate to one another with primary key, foreign key relationships, things like that. So Unity Catalog allows you to easily explore all those things on top of your tables and do much more than that, right? Won't cover all these in depth, but one thing I also want to highlight is that if you're new to the data that your companies have made available to you, you want to just start exploring data, we also make that easily available for you in sample data. So instead of having to go to an editor and run select star from every one of your tables, you can easily just pick out those tables that you want to look at, identify some sample data, right? So I have my auto bill of materials or auto BOM table here that shows me the BOM ID for my make and year combination. So a couple of fictitious automotive products that we're going to be making here, and identifies the number of parts that we need for each of these vehicles based on their make and model combination, right? So I have some sample data identifying that list for me. I also have the ability to explore the details and metadata of my table. So I understand, where the data is stored, whether or not predictive optimization, things that will automatically enhance the performance of my table are enabled. I can view the permissions to see who has access to this data. And again, if you're an editor or an owner of an object, you can control these privileges at a much more granular level to say, this user or these groups of users should only have access to read. These groups of users should have access to write, etc. And then on top of that, you have access to things like history and lineage that provide you a list of things like who's using these tables, when was this table last updated. So in history, you can see when changes were made to tables across what versions. with Lineage, you can see what queries, what up and downstream assets within Databricks are people using this table for. So you can see here that auto bill of materials has a downstream table, auto part forecasts. So what that means is that this table, auto bill of materials, if I click on this lineage graph, it has a downstream dependency. This table is used to source the creation of this table. So Unity Catalog offers lots of these things to help you explore your data, get more familiar with it, and better leverage it when you're actually conducting your analytics on top of that. So that's a very, very fast and quick overview of Unity Catalog. This is the data that we're going to be using for some kind of simple analytics today, where we have a bunch of parts that we're forecasting, sales that we're forecasting. We have a list of suppliers, their location, where they're based, what parts we're sourcing from which vendors. We have the supply chain kind of master table that identifies what tier suppliers we're pulling each part from, identify what potential bottlenecks there may be between tier 1, tier 2 suppliers, et cetera. So these are the tables that we're going to be leveraging and conducting some analytics to make sure that in a situation where we see an increase in spike or demand, we actually know which parts we need to go in and order more of to satisfy that sales demand, right? So I touched on Unity Catalog. I mentioned to use Databricks SQL, you need two things, data and compute. So let's talk about the compute now. So in Databricks, under the compute tab, you'll see we have lots of different types of options for compute. Each of these options is something that is kind of purpose-driven for different types of workloads that you want to run on Databricks. So think about all-purpose and job compute as generic workloads. That might be things that you're using for development of an ETL pipeline or an ML model, or maybe you're doing some SQL analytics. It could be any and all those things. These are designed more for general purpose applications. But for using the SQL editor and other SQL functions like AI/BI, dashboards and Genie in Databricks, you're going to be leveraging SQL warehouses. So inside the SQL warehouse tab, you're going to see a list of endpoints or warehouses that you have access to leverage for analytics in Databricks. So if I go to this endpoint here, I can see I have access to one endpoint in this warehouse. This compute is running, it's turned on, it's available for me to use. If I go into this, I can see some details about this endpoint. So this endpoint is showing me that it's running. It's a serverless endpoint. It's an extra large cluster. It will auto stop after a certain amount of time. This just allows me to see the details for how my warehouse was configured. Now, in that environment, I actually don't have access to create my own. So let me log in real quickly to another environment where I can demonstrate what that might look like on the compute tab to create my own. So I'll dive in really quickly here to create a new SQL warehouse, and you can see what that looks like. So I'm just going to call this SQL warehouse test Eric. So a warehouse is just the compute that you use to run your SQL-based workloads. The things that you need to define are how large of a cluster do you want? Think about this as the vertical scaling component. How large of a virtual machine do I want to run for my workloads? And the choices, why you would pick an X small versus a 3X large depend on, I'll say, primarily two things. One is the size of the data sets that you're going to be running. And then two, the concurrency or the number of queries that you're going to be running against that. Of course, there's some other complexity things like the types of queries that you're running, but data volumes and concurrency are a huge part of what dictates which size you would want to leverage. So for this, I'll just select an extra small workload. And then I mentioned that was the vertical scaling component. The next one here is horizontal scaling. This allows you to add many different clusters. So this helps out with some kind of variable demand in things like concurrency. Let's say you have spikes throughout the day where you want to be able to handle auto scaling. So maybe you have some users around the clock 24/7 that are running queries, but those workloads get much more intense during business hours in the United States. You want to have auto scaling kind of handle that demand and spike as more users get active into the warehouse. You can increase the scaling parameters to handle that volatility in demand as you go. Now, the last thing you need to define is the type of warehouse. You want to be able to run a warehouse that can handle the performance workloads, the performance of the workloads that you need to run, We always recommend using serverless with Databricks. That gives you the best bang for your buck. This is what we leverage for all of those price per performance benchmarks in Databricks. The reason for that is that in serverless, Databricks has added lots of different optimizations and things that we control the underlying compute engines and the virtual machines that run the warehouse. So we can inherently handle the optimization of the queries a little bit more effectively than we can if we have to do that on other VMs that are just simply leveraged from your cloud providers. Pro and Classic are certainly good options as well. You may not have serverless enabled in your workspaces, so in those cases, recommend choosing Pro over Classic, again, for the feature support and better performance over time. So once you choose those things, you create a warehouse that gives you access to run queries, right? So now we have our compute. We're going to be covering the SQL editor today, but if you needed to use this compute outside of the Databricks environment through one of your partners, like a BI tool, a data modeling application, other applications that you want to connect to, right? You can tap into using the SQL warehouse and endpoint and find the details for how to do so through the connection details tab, right? So all these things are really good to help enable your SQL-based solutions in other applications. Last thing I will mention is that on your SQL warehouse clusters, I didn't have access to it in the other one, but if I go into one of these existing tabs, as long as you have the appropriate permissions, you can also see a monitoring tab that will give you some sense of the workload, demand, concurrent queries, peak query count, query history, right? So within Databricks SQL, you have the ability, as long as you have the appropriate permissions, to monitor and manage all the different stats on top of your warehouse, right? So I will pause my kind of walk through there on the data exploration and compute, because those are the two things that we need to get started. But let's now dive into the SQL editor and actually start running some queries, doing some analytics, and showing you some of the features in the Databricks platform. I'm going to do a quick pause again, because I don't see any questions coming through in the chat, which certainly is okay, but just a reminder, if you have questions, please do share them in the chat. Yeah, I don't see anything that's blocking it, so you should be able to add them. If you can't, we'll have to figure that out for the next time. All right. So in the navigation panel on the left-hand side of the Databricks platform here, you have the SQL kind of collection of different products built in under the SQL tab. So we're going to start out with the SQL editor. We're going to cover SQL editor, queries, alerts, and then query history today. Next week, we'll cover dashboards, and the week after, we will cover Genie. So with the SQL editor, really the use case for using the SQL editor would be somebody that wants to write their own custom SQL queries. So this assumes you have some amount of technical knowledge and know-how to write your own queries, build some analytics on top of that. You also can leverage Databricks Assistant to do things like generate queries. So even if you don't know how to write SQL today, maybe you're still learning, you're a new analyst. Thanks for confirming, Will. You can use the Databricks Assistant to help out with creating queries based on something that you're asking in natural language to generate code. So inside of the SQL editor, if you want to pop up an Explorer for Unity Catalog to search your data, you have a quick little pop-up option to do that. You can open up the Assistant, where I can ask things like, generate a SQL query that identifies duplicates in a table. This will generate a SQL query that I can use. And it's also pulling back from some data that I've also recently used. It generates an automatic query for me that tells me, here's how you can identify duplicates based on records that have a count greater than 1 for these combinations. So if I have a table that I want to identify duplicates for, I can customize and tune this query, port it over into my editor that you see on the left-hand side here, and run my query, right? So the Assistant, the Catalog Explorer are all good resources to refer back to help out with your analytics. But let's start now with a very simple example, right? So to run a query, it's very simple, right? Run a select statement, hit Shift Enter, or hit Run on here. Now I've automatically selected the catalog and the schema that I want to use. You don't have to do this. This is just an option. So if you run a query like this, let's say I pick a different one here, like ad tech data, right? Ad tech data bronze. If I run this query, like select star from auto sales, it tells me I don't have permissions on the catalog that I'm running against. So I just need to go back and select the one that I'm running, or specify the entire catalog and schema name in my actual query itself. To simplify things, I'm just going to go back and select the new catalog, or the catalog and schema that are correct for my table that I have permissions on to run my query, right? So I'm just selecting data from auto sales. So this shows me for all my vehicles, the sales that we've had over the past month, the number that we've sold over time. So now from here, with my query results, you of course can do things like export data, download it, etc. But as much as possible, we don't recommend that unless it's required, because that just creates a copy of your data, an offline version, if you will, that isn't connected back to your data sets. So we want to make sure we can enable you as best as possible to use the platform where you're always connected to your data live as much as possible. So once we generate a query, run the query and see the outputs, you can also do a few other things. You can add things like visualizations or filters or parameters. So this helps out with an analyst who's looking at data. They want to be able to visualize it. I can't tell by looking at this chart which of my vehicles or which of my products is the highest selling one over time. So I might want to create a chart that shows me that very easily and simply, right? So I'm going to go and hit the visualization option. I'm going to create a line chart in here, choose that X column as sales, choose a Y column, sales month, a Y column as the quantity that we're selling. This now shows me the total quantity that we've sold over time, but I may want to break this down by the vehicle type or vehicle program, as we call it. This allows me to see the different programs or the different vehicle names. So the year and the model type, I can now easily see from here that the Pylori is the highest selling vehicle that we have on the market right now. So if I hit save, this will now add this visualization as a second tab in this query's result. So I ran this query in the SQL editor. It allows me to now look at both the raw results and that line chart in real time. I already had a copy of this one created, but you can see it's really easy to create, just kind of point and click, identify the fields and parameters that you want to leverage to visualize. So it helps out with that flow of looking at data and exploring it in a visual fashion. Some things that you can also add are things like filters. So if I wanted to be able to add the option for somebody to filter on a particular column with a UI option or toggle, I can do that here. You're going to see an option or a way to do that with a parameter in just a minute. But these are things that you can add into your queries. The nice thing about all of these queries that you see, each of these different tabs that I have open, these are different objects that you can save, store, and share with other users. So for example, this auto sales query is one, obviously it's very simple and basic, right? But let's say this is a visualization that, I'm an analyst. I start my day off by looking at this chart, and then I conduct some other analysis from here, right? I can save this object in my Databricks workspace. This auto sales query, once saved, indicated by that green check mark, this is now going to appear on the left-hand side under queries. Auto sales query is shown here. If I click that, it takes me back to the exact same screen, and you can see it already has those line charts populated, right? You may have to rerun the query, every day, but you can also define a schedule. So again, let's say you had the same query that you wanted to run every day, so that when you come in, start your day in Databricks, you have up-to-date databases, up-to-date data in your query results. You can do that very easily through the scheduler in Databricks. So a question about which compute warehouses it uses. You can, as the workspace admins, you can identify the default warehouse that you want to be chosen for SQL editor, Genie, and dashboards, etc. But you can also change this. In this environment, maybe not the best example, I only have access to one warehouse. But when you look on the right-hand side over here, to the right of the run and then the catalog schema, there's an option here that lists the warehouse you're using. If you hit that drop down, let me go back over to this other environment where you can see I have access to many different warehouses. So as long as you have the appropriate permissions to these warehouses, you can change this to any and all of these that you have access to. So let's say, for example, you're using an extra small warehouse indicated by that XS here. You might be running queries on a much larger table where you need more capacity. You could flip over to an XL warehouse, which with much more capacity to run your query. And you can also see indicated on the query list here, which ones are active and running, which ones are not. So the ones that indicated by green means that warehouse is already running. So if you run a query, there's no wait time for that warehouse to start up. Whereas if you selected one of these other options and it was, for example, a pro or a classic warehouse, you might have to wait a couple of minutes for that warehouse to actually spin up. Serverless warehouses, on the other hand, spin up in a matter of seconds. So another reason why we always recommend serverless is just a better experience, faster startup, better performance. So in this example, I only have access to one. That's what it shows. Okay. So this is a very simple query, right? But you saw already how you can download data, create visualizations, and then further conduct your analytics and queries on top of that, right? So now let's get into some other examples about kind of a simple simulation where I want to get some amount of inventory on my data. I want to see what parts do we currently have in stock, right? So I have a query. I'm just going to copy over into my tab here. Let's pick this query here. This query identifies the current inventory that we have for all of our parts. And again, the scenario where we're going to be simulating very simply here today is we have a number of these parts in stock already. We're going to be simulating a case where we have an increase in demand. We want to know, are the amount of parts that we have in stock going to be sufficient enough for all the different products that we need to build and manage for a generic sales increase by a certain percent, right? So this is our inventory data. Just mark that here, right? Inventory data. Now I'm going to copy in another query that will tie in my demand data. So this has, sorry, I just need to copy this query in here. This is our current demand. So I'm going to select the part number, the total number of vehicles that we are expecting to sell with our current forecasts. So this table, auto sales forecast, is one that was generated based on our historical sales, and it already has produced a forecast. We have an ML model that's creating these forecasts, populating the data in a table, easy for us to leverage for analytics. And now I want to see how many part numbers do we need in order to satisfy the current forecast, right? So this tells me how many parts we need to satisfy the demand for our forecasts as they currently exist. Now, let's say I want to kind of add some additional constraints here that say I want to forecast something different than our forecast entered into the system, right? I want to see this increase in quantity needed based on a multiplier. That multiplier might come in, older map, just going to delete that tab real quick. This might come in through kind of a what if analysis where we're simulating some type of scenario like an increase in sales, like a 5% increase across the board or a 20% increase across the board. You can do this very easily in Databricks by adding colon and the name of the parameter that you want to add. So like you saw before in the plus button where you can add a parameter, you can do that through the SQL editor here as well. Using that colon notation, there's also another mechanism to do that for query-based drop-down lists. But basically what this allows me to do is enter a value in this UI box that will get input into that query so I can simulate some type of value. This input could either be a text value, numerical, a drop-down list of values that I want to input. In this case, I'm simulating a number. I want to be able to input a percentage increase. So I'm going to just simulate, for example, a 20% or 1.2 in terms of the actual number increase in quantity needed, right? So this shows me now in this query that percentage increased on top of the current demand, right? So this shows me how many parts we need. I now need to combine that information with our inventory to see, which parts we're not in stock. Which ones do we have insufficient stock for that we need to place some orders, right? So I have another query here that identifies all these things kind of combined in one. So I just kind of took those two queries that I copied in. I have that increased quantity needed query here that I'm going to alienate or alias as future demand. I'm then going to create another query that I'll alias as inventory. Same thing that we saw here, pulling from our auto supplier sourced table. So now we're combining our already sourced stock of parts with our increased forecast demand. We're going to identify which products we're short on supply for. So we're joining these tables on part number. So I have the join between inventory and future demand. Of course, you could have written this entire query out on top of your tables, but we're just joining on the part number to these aliased queries already pulled from our tables. And then what we're doing is creating a statement that identifies, very simply, do we have enough stock for this query? So when we have the total quantity sourced already that is greater than or equal to the amount that we're going to be needing, then we have sufficient stock. If it is less than that, then we have insufficient stock. Simple case statement, simple logic, but you can see that it's really easy to plug and play this type of scenario. So I have input a demand of, or an increase in demand for 20%, right? I can very easily change that to 5%. Rerun the query, get the results, right? So that kind of what if analysis is very easily done through Databricks. You don't have to go back and update, rerun the query, save the results in an ad hoc fashion. You can do all this in a simple query. We'll show how to do this in a dashboard as well. But this allows you to identify, which parts we have insufficient stock for, right? So this is, kind of a walkthrough and a very simplistic example that identifies, something very real to a lot of folks in the supply chain space. You want to be able to answer questions like that. Can we meet demand? How to identify all the parts that we have in inventory? How do we relate our data sets from, one system, one database application to another? Databricks allows you to do all of those things through the power of Unity Catalog and Databricks SQL. Some of the features that we have in Databricks SQL, like the visualizations, the parameters, the exporting, all allow you to natively work in the solution and in the fashion that you want to accomplish your tasks. Now, I saw another question a few minutes ago about, how do you combine different data sets in Unity Catalog, or how do you leverage data from maybe different applications? I mentioned in the slides that you can use Databricks as kind of a central hub for SQL analytics, whether you have data that's in Snowflake, SQL Server, Azure Synapse, Postgres, tons of other databases. You can use something in Databricks called query federation, by which you set up a connection from Databricks to those databases and register those databases as a foreign catalog. I don't actually have an example of that in this demo, but let's say that's a situation that you had. You could very easily then look at those other catalogs. They would show up in the same list as what you have here, and you can write queries that combine data between these different applications. We'll push down the queries for those other systems into the other engines like Snowflake, SQL Server, et cetera, retrieve the results back, and then let you run your analysis connected with other data that you already have in Databricks. So it makes it really easy to work with all of your data in one location, even if the data isn't actually physically stored in a Databricks managed location like S3, ADLS, or a GCP bucket, right? So hopefully that helps in case you're using data that isn't actually stored in Databricks as well. You can do things like that through the external data registration for federated data catalogs in Databricks, right? So that covers kind of an overview of the SQL editor and its features. Again, somewhat simplistic example, but hopefully applicable to what you're all looking for. We covered how to run queries, how to identify or write out the table names of the objects that you're trying to query. There are certainly loads of other functions that we support. I'm not going to get into all of them today, but you can certainly look at our documentation to see a list of all the different query types that are supported, functions that are supported, things like AI queries, correlation analytics, text functions, right? All the different and standard SQL support that you would expect and more. are all available on Databricks. So if you're running queries with complex functions, you can also write your own custom functions in Databricks. Register those in Unity Catalog. Those would show up as functions that other users can leverage on a repeated fashion rather than having to redefine those. You can also leverage the query editor to create tables and assets. So if I wanted to create a table or a view or another object from here, I can do that. If I wanted to put this into another catalog, like shared Eric Lynn's test table as select star from demos Genie, you can see the autocompletes filling out the table names here, manufacturing, operations planning, auto bill of materials. I can create tables. I can run select statements. I can run merges, inserts, right? Any SQL compatible function you can run from the SQL tab in the editor that you see here. Going back to what I also shared in the beginning about this example of a saved query. So auto sales query is one that I've saved, right? That shows up now in my queries tab here. On the left-hand side, you can see all the saved queries that you've run under this tab. What that allows you to do is also, I showed, I think a minute ago, how in the SQL editor, you can schedule a query, right? I can schedule this to run every day, every hour, whatever cadence is you need to run that query. Just caution, if you do schedule that, it means that there is going to be compute that's running constantly against that. So just make sure that you're being cognizant about what queries you schedule and how often. But let's say you had a script that handles something like an insert or a merge that you want to leverage as a part of an ETL pipeline, right? You can also do this through the Databricks ETL jobs and pipelines feature called workflows. So if I have an ETL pipeline, sorry, let me go back here real quick. I just want to create a simple job. I can have a series of tasks that might handle something like ingesting data from another application that I then need to transform from maybe my silver layer data that is not fully cleansed and ready for analytics or for my BI reporting solutions, and I need to run this other SQL query. You can do that through the workflows tasks here and leverage the SQL object. The SQL object allows you to pick a SQL query that you have saved in your workspace and run that as a part of a workflow. So again, imagine you have a scenario where you don't want to run this query in isolation. You want to run it as a part of a repeated process that might transform, serve, or make your data available for other applications. You can do that through the workflows. Again, not the major goal of today, but hopefully maybe as an analyst, you can see why that would apply if you need to make data available in conjunction with another part of your ETL or analytics process. So under queries, we covered that. A couple of other things I wanted to cover are things like alerts. This is one of my favorite features in Databricks. I know in my past as a data analyst before I came to Databricks, I constantly had tons of questions that I would be getting asked on a regular basis. And they're ones that maybe were a little bit more complex. I had to do some sequential analytics or write multiple queries with subqueries to get an answer. But I really just wanted to know like a trigger, or I wanted to know if some condition was met and get notified about that rather than having to come to the editor every single time. That's kind of the use case for alerts. So an example that I can give in my past is I worked for a financial company where after we rolled out a new product, I had to produce, or I was frequently asked questions by leadership like, how many new applications did we see in the past couple of days? I could show them that in a dashboard or a report, but I would then get some other ad hoc questions like, well, I wanted to understand like when do we see a spike in applications for people with a specific FICO score range or people in this customer segment? Can we get an alert when we get a spike in any kind of trigger like that? In the supply chain sense, you might want to understand on a daily basis, like, are there any parts that are getting flagged as low supply? So that same query that we ran before, you can also then set up an alert to say, if we're seeing parts identified as low supply, you want to be able to take action on them, right? You want to know in advance, and do something about it rather than have your actual supply chains fall behind and fall back on your metrics. So with SQL query alerts, you can set those types of things up. It's very easy to do. Basically, you identify the query that you want to run. I'm going to pull out, oops, let me copy paste that example here for that demand. Go back into alerts. So you basically populate the query that you want to run, test that the query is valid. Let me go back to the existing one. I may have copy pasted something wrong. Try this one more time. There we go. I basically want to know, I've now filtered my result in the query to only parts where we've identified insufficient stock. So in the event where my total count of the records that I see in this query, if that result is greater than 0, I want to be notified that we're out of stock on certain parts, right? So I've now added myself as a notifier or a notification recipient so that in the event that this query triggers a result, I'll get notified in my inbox. So when I start my day, I will see before I even run a query myself if we're actually out of stock. So really applicable for a lot of business users or applications where you may not want to go through the process of running your query or refreshing the query and dashboard every day. You can get an alert based on a specific functionality like that sent to your inbox. So once you do that, you'll also then see, when the alerts are triggered. You can always at any point in time edit it, run it on an ad hoc basis, share this with other users, etc. And you can also integrate this with other workflows. So you can see here some of the options, like I can set up a Slack-based alert. I can set this alert up through a webhook to Slack, Teams, other applications, right? So it just extends the power of where those notifications can go and helps to solve some business challenges about making sure your parts are in stock. Saw a couple questions in the chat about federated queries, query cache. I will cover those in just a minute. Last thing I wanted to reference in the editor here is the query history. So you can see at any point in time the queries that you've run and have access to see, the time that those queries took with a duration, the endpoint that they were run against. So this helps out for things like performance tuning and testing, monitoring and auditing, things that maybe an analyst is not always responsible for, but are all things that are natively captured through Databricks to make it easy for you to refer back to. I know I've gone through this in the past where I run a query. I can remember exactly what day I ran the query, but the system I used at the time didn't store history very easily and efficiently, right? Through Databricks, I can very easily find and query data on a specific table or a specific date against a specific warehouse, right? Easy to find all of those things. So that's really all that I had to walk through today. Again, we're going to walk through how you can build out more complex visualizations through dashboards and Genie in subsequent webinars. So please do join us again in the next coming weeks. Let us know in the chat as well if you have specific feedback on things that you would like to see in those in advance. That way we can make sure to cover those as well. But answering a couple of questions here. When you're running federated queries, yes, you are running queries against Databricks compute because you're using our platform to run your queries, and then you're also using compute in another application. However, the benefit that you get through it is you are unifying all of that data where it may not have been possible through another application. You may have had to extract data and then join them through some other system. Just kind of adds another headache, right? So the federation solves a problem. It doesn't necessarily solve every problem, but it does help make your data available in one system. Now, there are certain conditions, things like today, if you have join clauses in a federated query, those are not actually pushed down. So we basically retrieve the results into Databricks, do that that joining and consolidation in Databricks, and then can subset results from there. However, that's another area of performance optimization and tuning that we're working on. So stay tuned for updates to federated query pushdowns coming in the future. Query and warehousing cache. Great questions and topics. I will admit I didn't put a ton of content in here about some of those more technical things that are behind the scenes, like how the warehouse is actually run. But yes, there are absolutely query caches and warehouse caches so that when you run a query and run the same query again, that result is cached for your individual user. for a duration of time. You can set some parameters and toggles on the warehouse to say, I want cash contained for this amount of time, maybe an hour or 24 hours, so that, again, it helps out with performance, especially for BI workloads. On top of that, there's also a warehouse cache. So if you run the same query and then another user runs the same query, they can also benefit from that same cache and have a better experience when running the same query that you've run as well. So there are definitely things that are already built into the warehouse solutions for caching to make it easily available to get the best performance without you having to tune tons of knobs on your own. Question just came in. When we add the parameter to the query, can we view results from multiple inputs and compare them? Good question. If you have, in this example, one parameter that I have defined in here, I am just using one value, like, simulating a 5% increase in sales or a 20% increase in sales, and doing that. You can certainly add others. So if I had copy this line and this query here, add another parameter, %2, you can do the same thing, right? So this, you can't directly compare, not that I can think of, the output of two unique values in the same parameter in the same query output, but you can leverage multiple parameters in conjunction with filters as well to compare those outputs. So if I wanted to compare 20% increase to 5%, could do that in here as well. %2. Oh, I just need to change the name of my, actually, you know what? Let me go back to here real quick to demonstrate one quick example of what you can also do with the assistant is diagnose errors on queries. Didn't run into an error before, but it tells you exactly what the problem is with your query. And you can actually see, it tells you exactly how to fix it. It automatically adds a solution that changes my query. I can port that back over into my query, rerun it, and it populates the results. One thing I didn't show before. So there you go. And actually this query, I'm only using, in the results, I'm only using increased quantity needed 1. Down here, I'm not actually using 2, but I can add that to my results. So hopefully that helps to answer your question, Jimlin. Awesome. Well, we are at time. Appreciate the feedback, the questions, the engagement. And again, we're going to be running the other 2 webinars. I'll pull up the dates again. You should have seen another couple of sign-up pages on the similar one that you had for DB SQL. So do be sure to join us again for AI/BI dashboards in Genie. Even though the example we might be walking through is somewhat simplistic, it allows us to dive a little bit more deep into some of the features that we offer because we can't certainly simulate every scenario that you might walk through in your own day jobs with your own data. So hopefully this helps to give you a sense of how to do that on Databricks. So thank you all, and hope to see you again next week and the week after. One last thing, recordings. I don't believe you will automatically get a recording emailed to you. Unless that's changed. I don't believe that's the case, but you can always reach out to your Databricks account counterpart and they can share a reference link with you to get access to that recording. Yeah, good question. All right, thanks everyone.